an older version. Now we have a newer version that has an extension. So it extends out. So if you put it in the cooling jacket, you know, your eye could go right up when you pull it out instead of trying to see.
Also,
because of depth associated.
The LED right underneath it blinds you when you're trying to look through that lens.
For this one here? Yeah, this one is the older version. This is a lot better. It has a bigger field of view.
Oh, there's a little piece of electrical tape with the
Yeah.
process+sensors+corp number.
So,
Special black.
well, when you're looking through the unit, you know, it's you'll see the object that you're measuring. You'll also see a circular reticle that's etched on the glass inside, and whatever's in the circle is what you're measuring. And we'll show you on the video how that works. So, in addition to the through-the-lens sighting, why would you use through-the-lens sighting around a laser? If you're looking inside of a chamber and there's a window there and the sensor blocks the whole window, how do you know what's inside? So you have to look through the pyrometer to see what's inside, because there's no other visual way to get inside the chamber. Or if you're looking down a target tube that's red hot, you can look in here and see you're not measuring the sides of the target tube because the circle's in there, and if the circle hits the side, it'll measure the side of the target tube. This way you could focus it and align it to measure the bottom. So that's when you...
Small spot size.
Small spot size. The reticle almost defines the spot size, so it tells you how big your spot is. So there's an advantage as well. So that's the reasons why you'll go through the lens sighting. In addition, on the newer version, we introduced, besides extending it out, it has a little bit bigger field of view as well. So there's no parallax. When you go up, you used to move your head a little bit, you'd lose the image. Now you can see it a lot clearer, and you have more leeway and error in terms of the parallax. In addition, if you turn, for the high temperature versions, if you turn the optical eyepiece here, there's a filter. If you're looking, if you have a sensor that's 1000 to 3000 C, which is 5400 F, 5432, you're looking in that bright white hot, and you'll burn your eye because it's so bright. So you have a filter, an optical filter, a dark filter goes in front of your eye when you're measuring hot spots, or hot targets. So then you can just turn it the other way and it becomes clear. Sweet. The other Metis pyrometer has laser sighting, and we can demonstrate that. And here you can see you can loosen the lens, pull it out, and find your focus point, and then lock it by turning it clockwise. Locks it in place. And the last method of sighting is video sighting. So we're going to demonstrate this after the presentation, a few things here for you to get a little hands-on and take a look at how these things operate and perform. Here you'll see it goes to a standard video monitor, RCA jack, connector on the back of the pyrometer, connected to any monitor, and you'll get a real-time running temperature and video. So here you have our company name, the time, the emissivity. You'll see what the emissivity setting is, as well as the temperature. Here you're looking at a glass bulb here, and there's a filament in here. And this circular reticle, it's a little square here, that would define your target size. So whatever I'm measuring is within this reticle. And there's advantages of that where the last one we sold was a kiln. And on the kiln, rotating kiln, the cement kiln, they had already a visual camera. So what they needed a pyrometer, so they got rid of their visual camera and just bought our pyrometer, and now it goes into the operator's or control room. You could actually see the temperature, and you could see a visual of what's going on inside the kiln as it was rotating, and where you're positioned. In addition, you're getting the analog and the digital outputs on top of it.